What is annealing? Annealing in metallurgy and material science is a heat treatment that alters the physical and sometimes chemical properties of a material to increase its ductility and reduce its hardness, making it more workable. It involves heating a material above its recrystallization temperature, maintaining a suitable temperature, and then cooling. In the cases of copper, steel, silver, and brass, this process is performed by heating the material generally until glowing for a while and then slowly letting it cool to room temperature in still air. Copper, silver, and brass can be cooled slowly in air or quickly by quenching in water, unlike ferrous metals such as steel, which must be cooled slowly to anneal. In this fashion, the metal is softened and prepared for further work such as shaping, stamping, or forming. Advantages of annealing: it softens the steel, it reduces thermal stresses which occurs due to temperature gradient, it enhances and improves the machinability of steel, it increases the ductility of steel, it enhances the toughness of steel, the grain size of the steel is redefined. Purposes of annealing: to reduce hardness, to relieve internal stresses, to improve machinability, to facilitate further cold working by restoring ductility. Types of annealing: full annealing, process annealing, normalization. Full annealing: the process involves heating the steel to 30 to 50 degrees centigrade above the critical temperature of steel and maintaining the temperature for a specified period of time, then allowing the material to slowly cool down inside the furnace itself without any forced means of cooling. Hot worked sheets, forgings, and castings made from medium and high carbon steels need full annealing. Process annealing: this process involves heating of steel to a temperature just below the lower critical temperature, 723 degrees Celsius of steel. Usually, cold worked steel has high hardness and low ductility, making it difficult to work. These characteristics can be improved by process annealing. This process is usually applied to low carbon steel. Normalization: normalization is an annealing process applied to ferrous alloys to give the material a uniform fine-grained structure and make it less brittle. It involves heating the steel to 20 to 50 degrees Celsius above its upper critical point, soaking it for a short period at the temperature and then allowing it to cool in air. Heating the steel just above its upper critical point creates austenitic grains much smaller than the previous ferritic grains, which during cooling form new ferritic grains with a further refined grain size. The process produces a tougher, more ductile material and eliminates columnar grains and dendritic segregation that sometimes occurs during casting. Can you memorize what is annealing? Annealing in metallurgy and material science is a heat treatment that alters the physical and sometimes chemical properties of a material to increase its ductility and reduce its hardness, making it more workable. It involves heating a material above its recrystallization temperature, maintaining a suitable temperature, and then cooling. For inspiration: everything has beauty, but not everyone can see. Confucius.